Okay, so now that you have gotten an opportunity to practice adding and subtracting mixed numbers, let's take a look at some problems where you're going to actually have to borrow in order to subtract. Remember when you first learned to subtract and you had some problems that were like 21 minus 12? And you came over here and you go, well, how can I take 2 from 1? 1 is smaller than 2. And you kind of wanted to subtract up and then come over here and subtract down the right way. Well, you can't do that, right? So you would have to borrow from the 2, leaving a 1, making this an 11, and then you can subtract 11 minus 2 equals 9. 1 minus 1 is 0, so your answer is 9. Well, when you are subtracting fractions, similar thing can happen. Take a look at example 3 from page 300 or 299. I can't remember what it is. It's page 301. I was wrong on both accounts. So example 3 from page 301. It says 2 1/3 minus 1 2/3. Well, you can see that 2 is bigger than 1. So there's no problem here subtracting that. But when you look at the fractions, 1/3 is smaller than 2/3. We can't subtract that. So what we're going to have to do is we're going to have to come up with a way of borrowing. Now, when you borrowed over here on this problem on the right, when you took from that 2, you weren't really taking 1 from that 2. What you were actually doing was taking 10 from it because the 2 was in the tens place. So that 2 really represented 20. And you took away 10 of it and you were left with 110. And that 110 you moved over here and you added 10 to the 1 that was here. And that's how you got 11. So you didn't really borrow 1, you borrowed 10 and then added it to that 1, giving you 11. Well, when you borrow from a whole number to add to a fraction, you're not borrowing 10. You're actually borrowing from this 2 and you're leaving 1. And you're actually truly borrowing 1. So you need to add 1 to 1/3. Well, you can't just put that up next to the 1 that's above the 3 because that would give you 11/3, and that would be actually like adding 3 1/3 to 1/3. We're not going to do that. Instead, what we're going to do is we're going to add a fraction equal to 1. And we talked about fractions equaling 1 yesterday. We talked about 1 over 1, 2 over 2, 3 over 3, 4 over 4, any fraction where a number over itself is equal to 1. Well, in this case, I want to use 3 over 3 because of the common denominator. I want to be able to add 3/3 to 1/3, so I have to have a common denominator. So I end up with 1 4/3. And you're going, wait a minute, Mr. Man, that's an improper fraction. We can't have that. Yeah, I know. We actually want an improper fraction in this case. We want the top number to be bigger than the bottom number. That way, when I drag my negative 1 2/3 over, I can actually subtract. 4/3 minus 2/3 equals 2/3. And then 1 minus 1 equals 0. So I end up with just 2/3 for my answer. So that is how you borrow. There is another way of doing this problem called method 2. However, it only really works with small numbers like these. And so I really don't even want to show you it. If you want to look at method 2, it requires you changing both of these mixed numbers into improper fractions before you subtract. The only problem with that is if your numbers get bigger, it becomes harder to do because you get large numbers when you multiply. And then when you're done, you may have to still change your improper fractions back to mixed numbers. And what you end up doing is adding steps. So method 2, which requires changing mixed numbers into improper fractions, can require you ending up having to change improper fractions back to mixed numbers in the end. And so you end up just doing a bunch more work. So let's take a look at a couple more problems from the lettered problems before I turn you loose to do some on your own. Letter G on page 301 says 7 minus 1 1/2. When I write this problem vertically, I want to line up the whole number parts. So the 7 and the 1. Then the 1/2 would be here by itself on the right. I need to have a fraction to subtract that from. It would be like taking 0 and subtracting 1/2. Can't do that. If you had 70 minus 11, you would borrow from the 7, making it a 6 and making this a 10. You're going to do the same thing here. You've got to borrow from this 7, making it a 6. But now you need a fraction here equal to 1. Would you put 1 over 1, 2 over 2, 3 over 3? What fraction would you put here? Well, you've got to look at the denominator down here. We need a common denominator to subtract. So my fraction equal to 1 has to be 2 over 2 so that I have a common denominator. 2 over 2 minus 1/2 is 1/2. 6 minus 1 is 5. The bigger looking number is positive, so I end up with 5 1/2. Take a look at another problem. Let's go with H. The problem with letter H here is that I don't even have a common denominator to start off with. I have 2 different denominators. So on this problem, before I can worry about borrowing, I got to worry about getting on the same denominator. So what is a common denominator of 8 and 12? Whew. Well, remember I said you can start counting by the larger denominator until you find one that the smaller one divides into. So I'm going to count 12. 8 doesn't go into 12. 24. Oh, wait a minute. 8 goes into 24. 8 goes into 24 3 times, and 2 times 12 is 24. So I'm going to multiply 3 eighths by 3 over 3 and 11 twelfths by 2 over 2. So I get 5 9 eighths, 9 24ths. I actually got to multiply 8 times 3. And I get 4, negative 4, and 22 24ths. And I look at that and go, okay, well, that was hard work. But yet I'm still not done. Because even though 5 is greater than 4, 9 is smaller than 22. So in order to subtract these fractions, I'm going to have to borrow from the 5. When I do that, I'm left with 4. And I have to add a fraction to 9 24ths equal to 1. Well, because my common denominator is 24, the fraction equal to 1 I'm going to have to use is 24 over 24. Yeah, that's still only equal to 1, but it's got larger numbers because of the common denominator being 24. So when I get done, I will end up with 4 and 33 over 24 on top, and negative 4 and 22 over 24 on the bottom. I subtract my fractions because they are different signs, and 33 minus 22 is 11, which I put back over 24, and then 4 minus 4 is 0, so I'm done subtracting. 11 is a prime number and doesn't go evenly into 24. It's not improper, and it's not going to be negative. So my final answer there is 11 24ths. But yes, it required some steps. First, I had to find a common denominator. The common denominator of 12 and 8 was 24. I had to multiply by fractions equal to 1 to get my fractions over their common denominators. So I got 9 24ths and 22 24ths. I could not subtract 22 from 9, so I borrowed from the 5, leaving only 4, and I added a fraction equal to 1 with the common denominator 24 to 9 24ths, which gave me 33 over 24. Keeping in mind I borrowed from the 5, so I only ended up with 4 as my whole number. I drug over the negative 4 and 22 24ths and subtracted, and I only had to subtract 33 minus 22 and get 11 24ths as my answer. Why don't you go ahead and give the remaining letter problems a shot? All right, that brings us just down to this one last example on page 302, which says, an urban planner is designing a skateboard park. The length of the skateboard park is 102.5 feet. The length of the parking lot is 40 1/3 feet. What will be the length of the park and the parking lot combined? Well, since we are looking for what they are combined, that tells me what I need to do with my two numbers. I need to add them. So 20.5 feet and 40 1/3 feet. The good news is when I'm adding, I don't have to borrow. So I just need a common denominator, which in this case would be 6. And I'm going to multiply by 3 over 3 here, 2 over 2 here. And that gives me 120 3/6 and 40 2/6, which is 165/6 feet is the total length of the parking lot. Always checking to be sure that I don't have to reduce and that I don't have an improper fraction. All right, now that you've had an opportunity to see all the examples and write them down and hopefully get all those lettered problems, I would like for you to please stop the video and go on to the next assignment in the classroom.